Hello, I'm Jeremy Arnold, Senior BI Developer at OneBridge in Indianapolis, and I'm coming back to you today with another Intro to Power BI video series. Today we're talking about DAX and Measures. What are they, what do they do, and why should you use them? And in honor of the NBA playoffs, a healthy dose of NBA data coming at you, so stick around. Last time in this series, we talked about the introductions to Power BI, and what does that mean? What does the software do? How do you get data in? And all that kind of great stuff. But the next step is obviously to begin doing analysis on the data. One of the things that we recognize is that you can't just look at 50,000 rows of data, or 100,000, or a million, however many rows of data you have in a table, and just go, I know what that means. We're not really well designed to do that kind of thing. I mean, we can't just absorb that information visually. So what do? We aggregate the information. We do things like get sums and counts and averages and standard deviations and all sorts of really cool stuff that we use to take all that information and condense it into consumable pieces which allow us to make informed decisions. In Power BI, we do this with the creation of what are called measures. I have a data set here, and this example uses information from the National Basketball Association. There are two tables, and I'll show those to you here. One is NBA player information going back to I think it's as far back as 1978. Actually, you know what? Let's go ahead and take this. We'll sort it real fast just to be sure. Yeah, it goes back as far as 1978, and this is every player who played for every team, and this information actually comes from 538, and it is super detailed, advanced stats across a billion different categories. I mean, you can just see how wide this data set is, and there's tons and tons and tons and tons of stuff in here. All really great stuff. This is like the player stats history of record going back to 1978. The other data set I have is what I call the NBA team history. Why? I don't know why it's not showing up. That is very strange. Let's take a look here. Okay, yeah, so it's here. I don't know why it's not showing in there. Curse of the live demo. But you can see this information basically has every team's win and loss record. And I've made some changes here. I've done some manipulation to sort of clean this up a little bit. It's going back pretty darn far. Like in some cases, like we have records for the Celtics going back to the 1946-47 season. By the way, Celtics, you'd be surprised, they were not always a great franchise. Look at those first 4 years. That's a pretty poor winning percentage. And we'll talk about that a little bit more as we move along. So the reason why we're having this conversation is because data analytics begins with those aggregations. And in Power BI, we refer to those aggregations as measures. Measures are built on DAX, which is it's a fancy language that's designed to create these measures, and you can make calculated columns with it as well, but we're not going to really talk about calculated columns today too much. But that DAX, or Data Analysis Expressions language, it's a formula language, and it allows users to define custom calculations. And you usually do this to create, like I said, custom columns or measures. DAX is very powerful. There's all sorts of really cool stuff you can get to DAX, and you can really slice, filter, aggregate the information in a myriad of different ways that can each be really cool and interesting and provide you insights that you might not get otherwise. The other thing I like about DAX is that it's as a formula language, it's a very natural extension or evolution for longtime Excel users. If you're an Excel user and you start learning DAX, you're going to find that DAX is pretty simple from a formula perspective. And I'll sort of give you a quick example of that. So I'm going to look at this team history here. And you know what? I just want to do like a simple summation of the number of wins that have happened in the NBA across my data set. So, I have a table, and maybe we want to know actually the total of wins by team. That actually probably sounds better. So I have this. Now, just for this example, obviously I have a column called wins. I could throw this in and then say, hey, this is what this is, right? And that's true. That's a true record. But there may be a time where I want to manipulate measures against one another, and I need to have those measures explicitly defined to do so. So I'm just going to create a new measure. Right click there. And we're going to call this sum of wins. Not sum of wins, sum of wins. And this is a really simple one. Just sum from team history. And the nice thing about DAX as well in Power BI, it will you can sort of see everything that's sort of eligible. And there are calculations, which are table calculations. So I want to know team history of wins. It's pretty simple. And then if I put this in here, you'll see I get the same results as I did when I just put the measure into the table. But now I can use that measure as a defined item for other calculations. And we'll talk about why you might want to do something like that. But you can see the syntax itself, parentheses, comma, how things are kind of filtered. A lot of that should feel very familiar to Excel users. Now, there are some formulas which are significantly more complex, but you can, with a little bit of study, very quickly understand DAX syntax. And then you can really start creating some pretty awesome measures that allow you to do some really cool stuff. There's a couple things to note about DAX. A DAX function will always reference a column or a table. You'll notice when I was looking in here for the thing I wanted to sum, I'm going to just kind of remove this so you see the whole list again. You'll see it shows me columns or tables. I mean, it's what it is. A DAX measure will always reference a column or table. The only exception to that is when you have a DAX measure that references another DAX measure, allowing you to do sort of nested DAX computations. Those aren't necessarily always best practices, but a lot of times you can, when you're trying to do something quick and in a hurry and you have the computational power, you can do that very quickly and kind of layer DAX statements on top of one another instead of creating one long, super complex DAX statement. And that can actually work out really well. So it will always reference a column or a table. This reference will require adding filtering to a formula. And you can do that via a myriad of filtering commands to specifically get to the aggregation for the specific group of data you're looking to do. Let's say, for instance, you wanted to calculate the sum of win share by each team of total wins, right? So to do that, that's a pretty complex calculation. And I could reference, in this situation, multiple DAX statements like what I was talking about before. So DAX functions always reference columns or tables, and we could see this when we were looking at this quick measure this measure we made. You can see it will show either whatever tables are available or columns are available that can be referenced by the function. There is one small, well, not small, exception to that, and that's when you use DAX to make measures that are dependent on other measures. But even then, those measure-dependent formulae are using, at some point, DAX that referenced columns or tables. So, generally speaking, DAX will always reference columns and tables. The exception to that is if you're referencing other measures you've created, but they also reference at some point columns and tables. So if you want to reference only specific values from a column or table, you need to add filtering to the formula via one of the DAX filter commands, and there's a large number of them. And we're not going to get into too much detail on those today because those are maybe a more intermediate topic, but some examples that you could look to for reference would be things like the filter command, the all command, and the all except command. Those are pretty commonly used filters that you can use to get very specific information. So why would you want to do this? Well, we have here, we have the team, we have the number of wins they have, but what if we wanted to know what the percentage of wins is for a team of the total number of wins? Well, we have the summation, and that's nice, but that alone doesn't tell us anything. So we would actually need to create, or what we'll do here is we'll create a quick measure, total sum of wins, which will be sum, and this is just going to be a quick example here. So it'll be sum, actually we'll have to do that with calculate. So we'll talk about calculate a little bit more later. So calculate sum wins, and then we'll say all except, so all except, and then team history, and then, you just put this in here just so we have something. So you'll notice, if I did this correctly, and I think I did, so you'll see now, everything equals 56,246. Well, that's not necessarily super helpful, right? Because I basically removed all the filtering conditions from the formula, so it's just calculating the total. But now I could do something like this. So you measure percent of win share by team equals, let's see, sum of wins. You see the measure appears here, divided by total sum of wins, right? And I can put this in here. Oh, look at that. So the 76ers have had 4% of all the NBA's wins in our data set. And obviously the data set is not complete. But the nice thing is when you have this, I don't actually even need this total sum of wins here. The calculation will still work if the measure is referenced, even if it's not in the table or visualization we create. So that's just kind of a nice thing to know. So again, what we kind of talked about here is a little bit of an advanced topic, or an intermediate topic rather, but I did want to show you quickly what that would look like in a DAX environment. So a couple other things I want to sort of talk about things DAX can do. DAX includes functions that can return entire tables as results, and these functions can be used to provide input to other DAX formulas, which is really nice. So there's a calendar function. It literally makes for you a date dimension calendar. There's a calendar auto function, which allows you to, or the calendar function allows you to set like a start date and end date, and it tries to build out a date table from that. There's a calendar auto, which kind of does something very similar. Basically, you set a start date and it just auto-populates a date table. There is a calculate table function, which literally does what it says. It allows you to calculate a table that can be input into the data model. And there's a couple different reasons you might want to do that. So just be aware those are things that exist, right? And that's really important to note. DAX also has some really powerful time intelligence functions that will be a little more, they're a little easier to understand, I think, from a SQL perspective. So things like date diff, date add. And then there's some really unique functions like same time last year. So, hey, you want to do quick year-over-year calculations. The same time last year function will do that for you. As part of this, for your reference, we will include a link to Microsoft's DAX function reference guide, which also includes examples of the formula in use. It gives their syntax and stuff. And that's a really, really great resource. I actually use that resource a lot. I think it's a fantastic resource. And when I'm not sure what function I'm looking for, usually I can find it. I can find it there and then quickly put it into practice. So we'll provide a link to that. So now that we've talked about sort of what DAX is at a high level and done some quick examples with it, let's talk about what are measures and what are their purpose. So measures are generally aggregations of information in specific ways to provide a specific result. And we've shown one here, which is which is the sum, right? So we did the sum, and we kind of used that to get the percent of win share, and that was really kind of neat. But we use these measures because we need to understand what the data is telling us in some larger context, right? And that context is important because, as we mentioned earlier, we can't just absorb 100,000 rows of data into our head and be like, oh, I understand the mysteries of the universe, right? That doesn't quite work. However, if any of you out there figure that out, please feel free to let me know your osmosis secrets, and I'll be more than happy to steal those from myself. So we have these measures because they allow us to understand information quickly, they allow us to aggregate information, and they allow us or they can be used as building block steps to create other measures that that allow us to look for the specific information we're looking for. And these aggregated outputs provide context, right? That's really what it's about for us. It's about providing context that that can also be used in those subsequent measures, and that's why that's part of why we generate these measures in the first place. One of the nice things about measures in Power BI is that they are, like most everything else, fully contextual. So, we were able to create a very simple measure, the sum of wins. And look, we don't have any type of context behind this formula. It's very simple. But when we included the team, right, it instantly knew to provide that context. Likewise, I'm going to create a little filter here. Let's move this over here. And we're going to put the year in, right? So we have all these years. And I'm going to say, you know what, because I'm a Pacer fan and I hate myself, I'm going to look at the 1997-98 season. One of the best playoff series ever played, 1998 Eastern Conference Finals, Bulls-Pacers. I still haven't quite recovered from that heartbreak, being up 5 with 6 minutes to go in the United Center. Or was it the United Center then in Chicago? I don't know. Someone, if you're in Chicago and you watch this video, feel free to correct me about what the arena was called in 1998. But you can see, the Bulls were a very good team that year, had 62 wins. The Pacers had, 58 wins. That was the Eastern Conference Finals that year. It was a very, very good year. So let's just sort this real fast so we can see who did what. So, we're looking, the Bulls had 62 wins. The Jazz had 62 wins. The Lakers and the Sonics were pretty good. RIP Supersonics, though. Sorry, Seattle. I know that probably hurts a little bit. But one of the things I actually want to note here is because we noted, this sums one was contextual. You'll notice this percent of win share by team isn't. And it doesn't seem to make a lot of sense, right? Why are these all coming up with zeros only for the total be 0.02? Well, that's because this percent win share by team references that total sum of wins, and the total sum of wins, we've explicitly told it, in this case via the all except function, to not have any contextual filtering, except for the filtering we allow. So it's taking their 62 wins and dividing it by the 56,000 whatever, and it's saying, oh, well, yeah, that's like 0% of the total win share. And that's actually working correctly, but I wanted to show you that as also a pitfall that can sometimes happen as you start working with these measures. And you'll see in the total, well, there were 1,189 games. That's about 2% of that total win share. So that's one thing I wanted to note as well, is that when we created certain measures, we created them explicitly without context, and maybe we want to do that for reasons of comparing a total to, like, say, a book of business total. So I have client A, who maybe has 100 units of sales, and we have 1,500 units of sales total. Well, I'd want to know that client A is 1/15th of my total, right? Well, the way you would do that is you would create a total measure, which is not affected by context, and you would divide your contextual total by that total. So that's why you can see this is behaving this way. I'm going to go ahead and remove that to remove further confusion. So here we are, 1997-98, big surprise. Top 2 teams in terms of win share made it to the NBA Finals. Interesting to note, the Western Conference was clearly super competitive that year. I mean, the Jazz won 62 games, the Lakers won 61, the Sonics won 61, the Spurs won 56, the Phoenix Suns won 56 games. I mean, you had the 5th seed in the Western Conference won 56 games? Jeez Louise, that was a great year for the NBA, I tell you. And of course, the Pacers are sitting there as the 2 seed in the Eastern Conference, and the rest is history. But just kind of a look because I hate myself. So, but the reason why I bring this up is you can see that sum function didn't have any type of additional context. We didn't have to say, hey, filter by team name, or hey, when I filter by year, filter by year. We built it broadly and allow context to influence the measure. And that actually works out really well in most cases where we want to know, hey, if I want to know what the sum of something is, I generally want to know what that sum is by the context that I pass through to it. And the DAX measures are naturally really good at doing that. So, in this first part, we've talked a little bit about what measures are, what DAX is, and sort of how they play together and what they do, and provide us some quick examples. And we're gonna stop here, take a little break, and then when we come back, we're going to talk about a couple things I like to do for learning DAX. And we're talking a little about quick measures, and we're going to talk about just some general DAX stuff on your own. I hope you found this video helpful. If you have future questions, please don't hesitate to reach out to us for all of your BI needs here at OneBridge, and we hope to hear from you soon. Thanks so much and have a great day.